Tapping power from one motor starter to disconnect to another is feasible with proper planning and execution. The following steps outline the process. Firstly, disconnect all power to the enclosure before commencing any work. Safety is paramount. Secondly, install a dual tap lug on the top of the fuse disconnect for the larger starter. Ensure this lug is rated for the appropriate amperage. Thirdly, run a wire from the bus to the top of the fuse disconnect for the larger starter. This wire must be rated for the higher amperage of the larger starter. Fourthly, connect a second wire from the dual tap lug to the fuse disconnect for the smaller starter. This wire must be rated for the lower amperage of the smaller starter. Fifthly, tighten all wire connections securely. Loose connections can cause overheating and potential hazards. Sixthly, restore power to the enclosure only after all connections are complete and verified. Several considerations are important. Ensure the wire used for the tap between the starters is rated for the maximum amperage of the larger starter. This is crucial to prevent overloading and potential fire hazards. Choose a dual tap lug that is rated for the combined amperage of the two starters. This ensures the lug can handle the total current draw. Make sure the wires are properly secured and insulated to prevent any potential electrical hazards. Use appropriate connectors and insulators. Verify that all wiring complies with the National Electrical Code and local electrical codes. Pay close attention to conductor ampacity, overcurrent protection, and grounding requirements. Properly size the conductors based on the load they will carry, referring to NEC Table 310.15 for ampacity ratings. For example, if the larger starter draws 150 amps and the smaller starter draws 100 amps, the dual tap lug must be rated for at least 250 amps. The wire connecting the bus to the larger starter disconnect must be rated for at least 150 amps, while the wire connecting the dual tap lug to the smaller starter disconnect must be rated for at least 100 amps. Overcurrent protection devices, such as fuses or circuit breakers, must be sized appropriately to protect the conductors and equipment. The overcurrent protection device for the larger starter should be rated no higher than the ampacity of the conductor as specified in NEC section 240.4. Similarly, the overcurrent protection device for the smaller starter should be sized according to its conductor ampacity. Grounding is essential for electrical safety. Ensure that the enclosure and all electrical equipment are properly grounded according to NEC Article 250. This helps to prevent electrical shock hazards and provides a path for fault current to flow in the event of a ground fault. Use appropriate grounding conductors and connectors, and ensure that all grounding connections are secure and reliable. Consider using a separate grounding conductor for each starter, connected back to the main grounding electrode conductor. Check the voltage rating of all components, including the dual tap lug, wires, and disconnects to ensure they are compatible with the system voltage. In a typical 480 volts system, all components must be rated for at least 600 volts. Use appropriately rated components to prevent insulation breakdown and electrical hazards. Inspect all connections regularly for signs of corrosion, damage, or looseness. Tighten or replace any connections as needed to maintain a safe and reliable electrical system. Implement a regular maintenance program to ensure the continued safe operation of the motor starters and associated wiring. Label all wires and components clearly to facilitate future maintenance and troubleshooting. Use appropriate wire markers and labels that are durable and resistant to environmental conditions. This helps to prevent confusion and ensures that maintenance personnel can easily identify and work on the correct circuits. Document the wiring configuration and component specifications in a clear and concise manner. Keep this documentation readily available for future reference. Include information such as wire sizes, conductor ampacity, overcurrent protection device ratings, and grounding details. Consider using a wiring diagram or schematic to illustrate the connections between the different components. Use appropriate tools and equipment for all electrical work. This includes insulated screwdrivers, pliers, wire strippers, and voltage testers. Never work on live electrical circuits without proper training and precautions. Always de-energize the circuit and verify that it is dead before beginning any work. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated shoes to protect against electrical hazards. Follow lockout-tagout procedures to prevent accidental energization of the circuit while work is in progress. These procedures involve disconnecting the power source, locking out the disconnect switch, and tagging it with a warning label. Only authorized personnel should be allowed to remove the lockout-tagout devices and re-energize the circuit. Inspect the insulation on all wires and cables for signs of damage or deterioration. Replace any wires or cables with damaged insulation to prevent electrical shorts and hazards. Use appropriate cable management techniques to keep wires and cables organized and protected. This includes using cable trays, conduits, and wire ties. Avoid running wires and cables in areas where they could be exposed to physical damage or excessive heat. Ensure that all electrical equipment is properly ventilated to prevent overheating. Provide adequate clearance around electrical equipment to allow for proper airflow. Do not block ventilation openings or cover electrical equipment with materials that could trap heat. Monitor the temperature of electrical equipment regularly to identify any signs of overheating. Use a thermal imaging camera or other temperature measurement device to detect hotspots. If any equipment is found to be overheating, investigate the cause and take corrective action. This may involve cleaning or replacing the equipment, improving ventilation, or reducing the load on the circuit. Be aware of the potential hazards associated with arc flash. Arc flash is a dangerous electrical phenomenon that can occur when a short circuit or other electrical fault creates a high-energy arc. Arc flash can cause severe burns, injuries, and even death. To protect against arc flash hazards, follow appropriate safety procedures such as wearing arc-rated clothing and using arc flash barriers. Conduct an arc flash hazard analysis to determine the potential arc flash hazards in your electrical system. Use the results of the analysis to develop an arc flash safety program and implement appropriate safety measures. Provide training to all employees who work on or near electrical equipment on the hazards of arc flash and the safety procedures to follow. Regularly review and update your arc flash safety program to ensure it is effective and up to date. Be aware of the potential hazards associated with electrical shock. Electrical shock can occur when a person comes into contact with a live electrical conductor. Electrical shock can cause muscle contractions, burns, and even death. To protect against electrical shock hazards, follow appropriate safety procedures such as wearing insulated gloves and using insulated tools. Avoid working on live electrical circuits whenever possible. If you must work on a live circuit, take extra precautions to protect yourself from electrical shock. Use a voltage tester to verify that the circuit is de-energized before beginning any work. Never touch electrical equipment with wet hands or while standing in water. Keep electrical equipment dry and free from moisture. Use ground fault circuit interrupters in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to detect small electrical currents and quickly shut off the power to prevent electrical shock. Regularly inspect GFCIs to ensure they are working properly. Test GFCIs monthly by pressing the test button. If the GFCI does not trip, replace it immediately. Be aware of the potential hazards associated with static electricity. Static electricity can build up on surfaces and discharge when a person touches the surface. Static electricity can cause minor shocks, but it can also damage sensitive electronic equipment. To prevent static electricity buildup, use anti-static mats and wrist straps. Avoid wearing clothing made of synthetic materials, as these materials tend to generate more static electricity than natural materials. Use a humidifier to increase the humidity in the air, as dry air tends to promote static electricity buildup. Store sensitive electronic equipment in anti-static bags or containers. Properly dispose of electrical waste. Electrical waste, such as batteries, fluorescent lamps, and electronic equipment, can contain hazardous materials that can pollute the environment. Dispose of electrical waste properly by taking it to a designated recycling center. Do not throw electrical waste in the trash or burn it. Follow all applicable regulations regarding the disposal of electrical waste. Stay informed about electrical safety. Electrical safety regulations and standards are constantly evolving. Stay informed about the latest changes and updates to ensure that you are following best practices for electrical safety. Attend electrical safety training courses and seminars. Read electrical safety publications and articles. Consult with qualified electrical professionals for guidance and advice. Remember that electrical safety is everyone's responsibility. By following these safety guidelines, you can help to prevent electrical accidents and injuries. It is always recommended to consult with a qualified electrician to ensure proper installation and safety compliance. A qualified electrician will have the knowledge and experience to assess the specific requirements of your installation and ensure that it meets all applicable codes and standards. They can also provide valuable advice on selecting the appropriate components and wiring methods. Tapping power from a larger starter to a smaller starter can be a safe and effective way to power multiple devices, but it is essential to follow all safety precautions and consult with a qualified electrician. Remember to prioritize safety above all else when working with electricity.